Hello everyone, we're in section 1.1 and we're going to go over linear equations, but first we need a definition of what an equation is. So an equation in one variable is a statement in which two expressions are equal. The values of the variable that make the equation true are called solutions or roots of the equations. So if we look at an example, the following are all equations. So I have 3x minus 7 is 10. This is an equation. There's the equal sign and I have stuff on both sides. X squared minus 15x equals the square root of 3x plus 4. This is an equation too. Again, we have that equal sign and stuff on both sides. That's the big difference. Where expressions, we just have some kind of expression, an equal sign. Here, both sides have stuff on them. Okay, so let's look at some linear equations. Okay, a linear equation. A linear equation in one variable is equivalent to an equation of the form ax plus b is not equal to 0. So here x is a variable. And a and b are real numbers. They can be anything, but a can't be 0. We need a variable in there, otherwise you just have some kind of true or false statement. And the way we solve these is we need to isolate the variable. So let's look at an example of how to actually look at some concrete examples and try to solve them. Okay, so here's our first equation. Directions make sense. They say to solve. Doesn't say simplify it, doesn't say perform the operation and simplify it to solve. So I'm looking for values that make the equation true. And this is a classic basic linear equation. One kind of way you can tell is that you have an x, there's your variable, and it's to the first power. You don't see any roots or things to the second power. So we need to isolate. We're going to try to get this x by itself. That's the goal. Get x by itself. So the idea is to use kind of the opposites. So here I see a minus 5. And remember, you have an equation, so you need to do the following. Work vertically down, and whatever you do to one side, do to the other. It's a scale, and it's got to be equal. So you pretty much do whatever you want as long as you do it to both sides. So the first thing, if I want to get this x term by itself, this 5 has no business being over here. So the opposite of subtraction is addition, so I'm going to add 5 to both sides. Here I am working vertically down, keeping the equal sign line up at the same spot. These guys cancel out. This gives me 3x. 4 plus 5 is 9. And I got one more step. Nobody cares what 3x is. We got to figure out what x is. This is multiplication. The opposite of multiplication is division. Good. Again, doing the same thing both sides, and we get our solution. And the way to check this is plug back into the original and see if it works. You can always check solutions to equation. Check. Alright, so let's see if this works. Here's my original equation. I plug a 3 back in for x. And if I get a true statement, we got it. So this is 9 minus 5. I'm wondering if this is going to be 4, and sure enough, 4 equals 4. We got it. The solution works. Alright, let's try another one. Alright, let's try to solve this monster. So I've got an equation, I've got an equal sign, I've got stuff on both sides. The directions make sense, it says to solve, so we're going to go ahead and do that. The nice thing is with equations, you can get rid of fractions, you're not stuck with them. Where expressions, you're stuck with fractions. So here, if I want to clear all these fractions, what I'm going to do is I'm going to take the least common multiple of 2 and 3. So 2 and 3, the least common multiple is going to be 6. So that's what I'm going to do. I'll multiply by both sides, and that'll clear all the fractions. You can only do this with equations. With equations, you can get rid of all your fractions. So I'm going to erase this, and I'm going to go ahead and do that. So multiply both sides by 6. So this whole side by 6, the whole side, and this whole side by 6. So let's see what happens when I do that. I gave myself some room here. So first of all, this left-hand side. This minus 4 is outside this parenthesis, so it needs to get multiplied by the 6 as well. So here when I multiply, remember, we're doing this with a purpose. That purpose is to clear these fractions. So here 6 divided by 2 is 3. I still have the x plus 5. Minus stays minus, and then there's the distribution is the 24 equals. And over here, the 6 is being multiplied to there. 6 divided by 3 is 2. We get a 2x minus 1. I've cleared all the fractions. I'm going to go ahead and do distributions here. So I see 2 sets. But this 3 does not get distributed as 24. It's outside the parenthesis. So I get a 3x plus 15 minus 24 equals 4x minus 2. Anytime you do distribution, you always collect up like terms, and there's like terms over here. So see, I'm working vertically down, that equal signs being the same space. I got a 3x. These guys are definitely going to come to give me minus 9 equals 4x minus 2. Okay, now let me make some more room here and let's see how we can finish this guy off. Okay, so at this point I need to get x's on one side and constants on the other. So it doesn't matter which way you do it, but I think it makes the most sense to move these 3 x's over there. So I'm going to subtract 3x on both sides. This minus is attached to that 9, so this is minus 9 equals 4x. I take 3 away, leaves me with x minus 2. Last step, I move that 2 over, and we get our possible solution, which is x equals minus 7. And now I'm going to do the check. So I'm going to plug in x minus 7 into the original for every x and see what happens. Okay, so here's my original equation again, back in all its glory before we messed with it, and I'm going to plug in our possible solution. So I'm just going to rewrite everything, and once I get to an x, I'm going to replace that with minus 7. And I'm wondering if these are going to be equal. So let's see, 1/2, this is minus 2, minus 4. I'm wondering if that's equal to 1/3. Multiply first, this is going to be minus 14 minus 1. 1/2 times minus 2 is minus 1 minus 4. 1/3 is going to be minus 15. And here I get minus 5 is equal to 1/3 times minus 15 is minus 5. It works. And we know we got it right. So it's a nice thing about equations is you can always check your work. Plug back into the original and make sure it works out. If it doesn't, that's not the right answer. If it is, you got it. So let's take a look at one more. Okay, let's take a look at this. So I've got an equal sign. This doesn't look like a linear equation right off the bat, but let's see what happens. So a natural thing to do here would be to do all the distributions. So I'm going to distribute this x in, and on this left-hand side here, I'm going to FOIL. So let's see what happens. This gives me 2x squared minus 3x is, well, this times this is 2x squared. This times this is minus 8x. Watch those signs. 1 times x is plus an x. 1 times minus 4 is minus 4. Remember, after you distribute stuff out, look for like terms. Working vertically down, keeping that equal sign in the same spot. This gives me 2x squared minus 3x is, let's see, 2x squared. These guys combine to give me minus 7x minus 4. Now at this point, it doesn't quite look like a linear equation because I see x squared, I see squared powers. But these two things are going to cancel. I try to move this over, minus 2x squared. They cancel on both sides, and sure enough, I do have a linear equation. Minus 3x is at minus 7x minus 4. Makes sense because this is in that section anyway. So if you're doing section 1.1 problems, you should get linears out of them. Alright, let's see. Move over here. I'm going to add 7x to both sides. That's going to give me 4x is minus 4, and last step, divide both sides by 4. And now we're looking at x is minus 1. And you're going to take my word for it, but I'll leave a check for you, but that will work. That is the solution. And I did lie. I got one more problem for you. So let's take a look at one more. Okay, let's try to solve this equation. So like we said in the previous one, we can get rid of fractions. So that's kind of nice. I can get rid of these x plus 3's on the bottom. So what I'm going to do is I'm going to multiply both sides, and they're both the same bottom. So by x plus 3. This will clear all my fractions. I'm doing this with a purpose, to get rid of the fractions. Keep that equal sign lined up. So here I'm doing that to cancel those out, and they do. Just give me 2x. And here I have to be very careful, because this 2 is separate from this, and it's not divided. So we're going to distribute. Here to here, I'm doing that to cancel out this x plus 3, and that gives me a minus 6. And here to here is where we're going to have to do distribution. See how every single term got multiplied by x plus 3, even that 2. Alright, distribution time. Remember, this minus is attached to this 2, so they travel together. It's minus 2x, that's going to be minus 6. Make sure you get that sign right. If combine up your like terms. It's going to be minus 2x minus 12. X is on one side, add 2x both sides. I'm going to go over here. So now this gives me 4x is minus 12. And last step, divide by 4, divide by 4. And I get our possible solution. Okay. But, so be careful. Always a good thing to try to check your work. If I plug this back into the original, what's going to happen? That's going to cause this bottom to turn into 0, because minus 3 plus 3 is 0. Minus 6 divided by 0 is undefined. You cannot divide by 0. So this problem actually has no solution. The only answer that could work causes a domain error, and you cannot divide by 0. So be careful. You can clear the fractions all you want, but if you get rid of all the fractions and the answer turns into something that causes a division by 0, then you get no solution, although it is very tempting to say that this is right. Always check your work with this. If you end up dividing by 0, the answer doesn't work and you have no solution. Alright, that's solving linear equations. See you next time.